Dear students, welcome to the lecture series on the topic engineering graphics. So today we are going to discuss about projections of the oblique planes. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. So in our earlier lecture deliberations, we have already discussed about the projections of the planes with when the plane was located in different positions with respect to the coordinate reference planes, that is horizontal plane and the vertical plane. The first case which we discussed was about the drawing the projections of the plane when the plane happened to be parallel to a given horizontal plane or the vertical plane. Then the second case we had discussed was when the plane was inclined to one of the reference planes and it happened to be perpendicular to the other reference plane. And the third case we have discussed was the plane which was perpendicular to both the reference planes, that is horizontal plane and the vertical plane. Now in today's lecture we are going to discuss about drawing the projections of the planes when the plane happens to be inclined to both the reference planes, that is horizontal plane as well as the vertical plane. So such planes, they are called oblique planes. So the oblique planes are the ones which are inclined to both horizontal plane and the vertical plane. So let us start with construction of the projections of the oblique planes. So let us read out the statement for question number 1. So here we have a regular pentagonal lamina of 25 mm side which is having one of its edges in the horizontal plane such that it is inclined at an angle of 45 degree to the horizontal plane and perpendicular to the vertical plane. And in the second iteration, the side on which it rests on HP is further inclined at an angle of 30 degree with respect to the vertical plane. So we are required to draw the projections of the lamina. So if we break these questions into two components, we'll see that this part, that is the first part of the question, we have already discussed in the previous lecture. That is, we are having a lamina or a plane which is inclined to a particular reference plane, which is horizontal plane in this particular case, and it is perpendicular to the vertical plane. So our starting point to this question will again be the same. That is, we will be assuming that the lamina happens to be parallel to the horizontal plane to begin with. We'll draw the front view of this lamina below the XY line because we have to draw the true shape of the pentagonal lamina on the horizontal plane, because the true shape will be obtained on the horizontal plane. Why? Because this first inclination happens to be there with respect to the horizontal plane, and we have already discussed this thing. Whenever a plane happens to be inclined with respect to a particular reference plane, to begin with we will assume that the plane is either parallel to or it is contained by that particular reference plane. And since this is a pentagonal lamina which is inclined to HP first of all, so we will assume that this lamina is parallel to the horizontal plane. And the second thing which is available with us, that this lamina is having one side located in HP. Since this lamina is having one side located in HP, so to begin with we will assume that the lamina is contained by the horizontal plane in this particular case. So in the horizontal plane, the true shape or the top view will be drawn first of all. Now the question arises that these are the two positions in which we can draw the pentagonal lamina below the XY line. Now we need to verify which position is the appropriate one for such a problem. So please see, once again we'll read out this question and find out one of these two positions in which the pentagonal lamina can be drawn. So please check. This is one situation when one of the edges of this pentagonal lamina happens to be perpendicular to the XY line. Whereas in the second position, we have got the lamina in a position that one of its edges, it is parallel to the XY reference line. So we'll find out just in a while which one of these two positions is going to be the correct one. So step number 1, we'll read out the statement and find out the correct position of this particular pentagonal lamina. So now please read out the statement. The regular pentagonal lamina of 25 mm side has one of its sides resting on HP such that it is inclined at an angle of 45 degree to the horizontal plane and it is perpendicular to the vertical plane. So let us pick up this case. If I draw the pentagonal lamina in this orientation and I am lifting this corner, that is whatever edge view will be obtained in the front view, if I lift that particular edge view from this corner, so it will be resting, this lamina will be resting on HP on one of its corners, not on one of its edges. Even if I am lifting my edge view from this side at an angle of 45 degree to horizontal plane, I will find that my lamina is resting on horizontal plane on this corner. But if I draw the pentagonal lamina in this orientation and if I am going to draw the front view, which will be an edge view, in the second iteration, if I lift this particular corner with respect to the horizontal plane, if I lift my edge view with respect to the horizontal plane through this corner, I will find that my lamina will be still resting on the ground, that is on the horizontal plane on this base edge over there. So that is why we can conclude over here that this is the appropriate position. But again, here also, if I draw the lamina in this orientation and I draw the edge view, I cannot afford to lift the edge view through this corner. Again, if I lift the edge view through this corner, again if I lift it at an angle of 45 degree with respect to HP, my lamina will be resting on HP on this corner. So this will not be appropriate. So what I have to do, I have to draw the pentagonal lamina with one of the edges perpendicular to the XY reference line, draw the front view which will be an edge view onto the HP, and then lift the edge view from this particular corner with respect to HP at an angle of 45 degree, so that my pentagonal lamina will still be resting on the ground on this particular edge over there. So this is the correct position of the lamina which has to be drawn, whereas this is the incorrect position of the lamina which has to be discarded. So now let us draw the projections of the line over here, projections of the oblique planes over here. So to begin with, step number 1, true shape of the lamina has to be drawn. So please check this out. This is the pentagonal lamina whose edge is given to us as 25 millimeter. So this is the 25 millimeter. We'll draw the external angles of the pentagon as 72 degree and complete the construction of this pentagonal lamina such that the edge length happens to be 25 millimeter. Next, let us do the marking. So we can do the marking of the corners over there, A, B, C, D and E. So having drawn the true shape, assuming that the lamina happens to be parallel to or it is contained by the horizontal plane. Now please see, now the question arises whether this lamina is only parallel to the HP or it is contained by the HP. Had we been provided with this information that the lamina is at a distance of 10 millimeter from the horizontal plane, we would have drawn the edge view over here. But we have been provided with this information that one side of this lamina rests in HP, because one side of this lamina rests in HP and this lamina we have assumed to be parallel to HP. So the edge view of this lamina will be drawn on the XY line or on the horizontal plane. So this is going to be your front view of the lamina, which happens to be the edge view. So you can see the front view points, they will be E dash, A dash, D dash, B dash over here, and C dash. So step number 1, as usual, we have to draw the true shape of the lamina, assuming that the lamina happens to be parallel to a given reference plane, and it will be parallel to that reference plane with which it is making the first angle over there. So it is making the first angle of inclinations with the horizontal plane. That is why it is parallel to the horizontal plane. So first, on the horizontal plane top view we have drawn. Then step second, we have drawn the front view of this lamina, and since one of the edges of this lamina after the inclination was contained by the horizontal plane, so we have to assume that this lamina is contained by the horizontal plane to begin with. So that is why its front view projections, which are an edge view, will be coinciding with our XY line. So having drawn the front view first and the edge view in the second step, in the third step we have to incline this lamina at an angle of 45 degree with respect to the horizontal plane. And as I have already explained, again you have two choices, whether you incline it this way or you incline this edge view in this way. So surface of the lamina, you can incline it this way, or surface of the lamina you can incline it with respect to HP at an angle of 45 degree in this orientation. Now let us see, if I incline this lamina in this orientation by picking up or lifting up this corner of the edge view, what I am going to get? I am going to get the lamina is resting onto the horizontal plane on one of its corners. Is it resting on one of its corners on HP? No, it is resting on horizontal plane on one of its sides. So since the lamina is resting on horizontal plane on one of its sides, so I cannot lift this edge view in this orientation. Reason, if I lift it in this orientation, my lamina will be resting onto the corner in the horizontal plane, not on the edge. So if this is the situation, then what I have to do, I have to lift my edge view in this orientation. That is, this edge view has to be picked up from the point C dash. It has to be lifted at an angle of 45 degree with respect to the horizontal plane or the XY line, such that this will be resting, the surface of the lamina will be lifted such that the lamina will be resting on ground onto this particular edge. That is, it one of the edge or one of the side will still be resting onto the ground. So let us do that. So step number 1 was the true shape. Step number 2 is your edge view. Then the step number 3 is the rotation or the translation. So this we have already discussed. So we are going to measure these distances, distance of E dash, A dash from C dash, and distance of D dash, B dash from E dash, A dash. So these point number 1, point number 2, point number 3, these distances will be marked, and we are going to draw same edge view over here which was drawn over here. This will be translated or rotated at an angle of 45 degree. So please check, this distance will be equal to this distance. Similarly, this distance will be equal to this distance. So having just rotated or translated the edge view from position number 2 to position number 3, now we need to draw the view number 4, that is the projections which will be obtained on the horizontal plane after the first inclination. So now what we are required to do, we are going to draw these projectors downwards from all these 5 points. Similarly, from the 5 points of the plan, we have to draw the projectors horizontally. Wherever the corresponding points they are located, the projections of the plan view in the 4th iteration will be followed. They will be determined. So please see the projection of A, they are moving in the horizontal direction. Projections from A1 dash, we have to drop them down vertically downward. Wherever both of them meet, we are going to get the location of the point A1. Similarly, projector through E1 dash, they are dropped downwards. Projector through E, they are dropped horizontally. They are brought forward horizontally. So wherever they intersect, we get the location of point E1 over here. A1 sorry, E1. Similarly, projector through B we have drawn horizontally, projector through B1 dash we have drawn vertically down. We have been able to identify point B1. Similarly, through D, draw the horizontal projector so that it intersects with the vertical projector which is coming through D1 dash. So we have been able to obtain point D1. And finally, point C1 is also located, which is the intersection of the projector through C1 dash, which is vertical one, and horizontal projector through the point C. So having located all these 5 points, so I can join A1, B1, C1, D1, E1. And having joined this, we can very well work out that this was the true shape of the lamina, that is pentagonal lamina, whereas this is the reduced shape or the shortened shape of the lamina. That is why we have said that this is the apparent shape of the lamina. And we have already known by now that apparent shape of the lamina will be shorter than the true shape of the lamina. So step number 1 was our true shape. Step number 2 was the edge view. Step number 3 was the rotation or the translation of the edge view. Step number 4 was the corresponding view. Now we have to draw step number 5. So step number 5 is nothing but it will be the rotation of the view number 4. So whatever the fourth projections we have obtained or projections obtained in the fourth view, they will be rotated at a particular angle which is given to us, that is the side on which it rests on HP is further inclined at an angle of 30 degree to the VP. So this figure A1, B1, C1, D1, E1 we are required to rotate or translate or transform at an angle of 30 degree to the vertical plane. You see here I'll draw a locus projector over here at an angle of 30 degree, and then I will transfer this picture over here such that the side on which it rests on HP, which is the side, please check, A1, E1. So A1, E1 is the side on which my lamina is resting onto the horizontal plane. So I have to tilt this particular lamina in such a way that this edge A1, E1 will be inclined with respect to the vertical plane at an angle of 30 degree. And another thing you can work out over here, this dimension has been reduced, this dimension has been reduced, this dimension has been reduced, this dimension has been reduced. Why? Because of this inclination. But still there is one dimension of this pentagonal lamina which is obtained as a projection in the top view, that is A1, E1, which is still parallel to or contained by the horizontal plane. This is contained by or it is parallel to the horizontal plane. So that is why this line we have marked as true length, whereas this is apparent length, A1, B1 is apparent length, B1, C1 is apparent length, C1, D1 is apparent length, and D1, E1 is apparent length. So we have to transform this picture or rotate this picture in step number 5. So you could have rotated it this way, you could have rotated it this way. So I am going to pick it up this way. So I have drawn this angle phi. What is angle phi over here? Phi is the angle of rotation of the true length. You see A1, I am talking about edge A1, E1 because the side on which it is resting on horizontal plane. Now this is the true length, still true length even after the rotation. So since even after the rotation this side is true length, so the angle which this side makes with the vertical plane, we have marked this angle as angle phi. So angle phi is equal to 30 degree, and now I have to draw true length over here. So please see how we can transfer this particular image over here. So please be very careful. I am going to first of all draw this locus line, and onto this locus line I have to transfer this picture. How this can be done? Very easily. I have to measure rectilinear distances only. Please see step number 1, even though I have not marked, but I will tell you Please check. This is point 1, this is point 2, this is point 3, this is point 4, and this is point 5. So you can mark 5 dots over here. First dot, second dot, third dot, fourth dot, and fifth dot. And once you measure this length, whatever are the positions of the 5 dots, I am going to mark it over here onto this line in order to perfectly transfer this line, this plane lamina over here, image over here without any error. So just see, this is my first dot, dot number 1, dot number 2, dot number 3, dot number 4, and dot number 5. So please check dot 1, dot 2, dot 3, dot 4, dot 5. Dot 1, mark dot 2, mark dot 3, mark dot 4, mark dot 5. Now from dot 1 and dot 5, please check, from dot 1 and dot 5, measure this distance. This is equal to this one. So distance of D1 from dot 5 is equal to distance of B1 from dot 1. So having measured this distance from dot 1, mark this point. Automatically you will get B2. From dot 5, mark this distance, you will get point D2 over here. From dot 2 and dot 4, you see no vertical distances are there, vertical distance is 0. So dot 2 and dot 4 gives you location of points A1 and E1, and over here A2 and D2. So dot 2 and dot 4 will give you locations of E2 and A2. And from dot 3, please see, this is my dot 3, measure this vertical distance. I am measuring only the rectilinear distances, please see. So I measure this rectilinear distance from dot 3, and from dot 3 location I am going to mark this up. So once again you can see I am going to repeat dot 1, dot 2, dot 3, dot 4, dot 5. So measure the locations of these 5 dots, 1, 2, 3, 4, 5. From dot 1 and 5, measure this perpendicular distance, mark it over here, mark it over here, you get 2 points of the pentagon. Dot 2 and dot 4, distance is 0, you get the location of A2 and D2. From dot 3, measure this distance, you are going to get location of point C2 over here. So this way you can work out the rotation or translation of figure number 4 over here in figure number 5. So in figure number 5, what is different? We have made this pentagonal lamina to rotate at an angle of 30 degree with respect to VP. And what is the point which we are focusing? The edge on which it was resting on the horizontal plane, that is A1 E1, has been transferred over here, and it is this edge which is inclined at an angle of 30 degree. So having located these 5 points over here, now the next thing is I will be locating the 5 points in the front view so that we can obtain the front view of this oblique lamina. So step number 6, we will be taking all the 5 projectors upwards. We'll be drawing all the 5 projectors horizontally from the previous view, wherever the corresponding points they are intersecting, just like as we have discussed before, all the 5 points of the front view will be obtained corresponding to this oblique plane which is inclined to HP as well as it is inclined to VP. So let us work out these projector. You see, these were only the markings just for location of these points. So that is why in the next step I have eliminated these reference lines. Now I am drawing the horizontal lines as well as the vertical lines. Let us find out the corresponding point. Just see, this is point A2. Point A2 is coming from below. Draw the vertical projector upwards. What is the projector of A1 dash horizontal? It will lie here. This will give me point A1 dash. Similarly B. So B2 vertical projector will be coming up like this. B1 dash horizontal projector will be obtained over here. This will give me location of B2. Similarly C2 projector we have to take vertically upwards, and C1 dash projector we have to take horizontally towards the right. This gives us the location of point C2 dash. Similarly D2, so D2 projector you take up, and D1 dash projector you take horizontally this way. That is why we call it corresponding view. And similarly, E projector you take it up, and whereas A1 dash projector is there, you get point E2 dash located over there in the front view. So having located these 5 points, so you can see that we have been able to complete projections of an oblique plane which happens to be inclined to both the horizontal plane as well as the vertical plane. So this is all about the discussion of the oblique plane which is inclined to both HP and VP. And please make sure that this orientation should be correct. If you are not able to select this orientation properly, so entire question will be going wrong. So again I repeat, step number 1, you have to draw the true shape below the below the XY line. Step number 2, you draw the edge view. Step number 3 is the rotation or the translation of this edge view of the front view. Then step number 4, you have got the top view which is the corresponding view. Step number 5, you have got the rotation or the translation of this top view plan which you had obtained previously. And step number 6, it is the corresponding view. So in these 6 steps, we will be able to work out projections of the planes which are inclined to both the horizontal plane as well as the vertical plane. So this is all about this particular lecture. So in the next lecture, we are going to continue with the projections of the oblique plane. So thank you very much.